So I don't know whether everybody was at Eric Berger's presentation earlier this morning. He made a reference to kooky ideas being presented on the FCC ECFS website in terms of comments. I told him afterwards that I felt a little self-conscious. Were you talking about me? So this is one of those, I think, that that might fall into that category, at least compared to everybody else that was submitting comments for 1864, which was a notice of inquiry for how to improve call routing for 911 purposes. So one of our use cases is actually improving routing capabilities in terms of both timing and accuracy of a location using fixed broadband connections. So before I get started, it's a small room, so I don't expect big responses in terms of sample sizes that are significant enough, but how about starting out with how many, by show of hands, have done either FaceTime or Skype on a tablet computer? Just about everybody. Okay. Does anybody have an Amazon Echo or a Google Home that they've tried voice calling on? A couple. All right. So that's probably skewed a little bit higher on a percentage basis than normally you would see on broader surveys, but still that number is growing every day. And I think one of the things that is we've taken so much time in order to advance regulatory and support for a variety of different 911 technologies. The consumer market is moving quickly and adopting many more communication devices than just, smartphones and landline phones that we've used for years. So what's really happened over the past pretty much 20 years is that home broadband service has grown from probably 20 or 30% penetration in 2004 to over 86% penetration today. So in the United States, just in residential installations, there's almost 109 million broadband connections. If you think about that network is sitting there in prime condition to be utilized for something like 911, both for any IP connected device, but also for providing location information through a dialogue with the ISPs. Of note, I came out of the broadband ISP world myself, and one of the things we worked on for years was landline telephone service. Well, landline telephone service has continued to be emphasized as the lifeline service. I can hardly say that a product today that has 40% penetration can be considered lifeline anymore. I do believe broadband, though, is a lifeline service for a variety of reasons. So connected to those broadband connections are the things we've talked about already, and we'll talk about more of them in a few minutes. But people are communicating today with all kinds of devices that have nothing to do with the smartphone or the landline phone. And so I think there's a great opportunity to provide both location information, call routing information, both out of band within the cell network for a smartphone, as well as open the doors for different types of video, talk, and text for any number of applications and devices that consumers are adopting quite rapidly today. That does a couple of things. Not only does that enable more devices that people already have in their hands, it also provides and adds more robustness to the 911 network today. So if you think about it, and we'll show this in a minute, you have a landline telephone that has access to 911, and you have mobile phones that have access to 911. So if 80% of calls are now going over mobile phones to 911, where there's a failure in that network, there's not necessarily a failover in all cases. In the home broadband network, even the business broadband network would be an ideal path for transporting media over those connections. The last thing I would mention about this is that the system that I'm going to describe that we've both prototyped as well as drafted some specifications for on a number of aspects also provides a two-way capability. So we're not just talking about inbound 911 location and communications. We're talking about things that were talked about this morning for wireless emergency alerts, where you can target messaging. So if you think about the cable television and broadcast television world, they've been under regulation for years to broadcast emergency alert messages just like the wireless carriers are required to broadcast text messages for emergency alerts. Fewer people are subscribing to home television service. More people are cutting the cord and getting their video via broadband. That's an ideal channel for also communicating emergency alerts that's being underutilized today. And the last thing is for law enforcement to utilize this type of service and technology to do real-time detection of, terrorist attacks or child pornography downloads and things of that nature. So we started off talking about things like Amazon Echoes and tablets, but if you kind of expand what all the different opportunities there are out there for different devices being adopted, we have had, the medical alert pendants for years that go through a different gateway, but those could be enabled for this purpose. You think of Wi-Fi baby monitors that could be enabled. My personal use case is that my daughter used to babysit for a family that lived behind us. If she had to pick up her cell phone and tell 911 where she was and what her address was, she wouldn't have any idea. And we didn't keep track of addresses. We just know where it is, and it's on the street behind where we live. So if they had devices like this in the house that were readily accessible and connected to their broadband network, they'd be able to use it. There are a number of accessibility services like Video Relay. There are now web-enabled refrigerators, which the prototype that we're going to demonstrate in a minute, I actually did some sample calls just using a refrigerator to Lowe's a couple of weeks ago. So I know there are a few of you that deeply are knowledgeable about this whole piece of how 911 is actually handled on each of the networks. So I won't go into many details, but I will kind of describe a couple of key characteristics that what we're bringing to the table and what is available today. So as I mentioned, about 40% of the households and declining have landline telephone. And that's an old system where a local information server known as the ALI database is populated when a phone number is provisioned for a customer. It has the address, including not just the street, but it's got the street, the unit, the floor, and where where calls can be dispatched to. And it's a pretty refined system that basically routes a phone number to the exact PSAP that's supposed to get the call. There's no guessing. There's no calculation being done. It's not an estimate. It's an accurate delivery of an address. In mobile, that's the location is algorithmically defined. The routing is based on tower proximity. So you may or may not get to the right PSAP when you call it. And you have an estimated target area where the call is coming from, which traditionally is 50 to 300 meters. Obviously, with what Apple and Google are doing today with their technologies, that's improving, at least at the ground level, but you still don't have a vertical accuracy on where somebody might be in a multi-tenant building. What we're proposing here is an architecture that very much simulates what's taking place in the landline voice world. And that is when an ISP provisions service at a house, they know where their customer is, they know where they have provisioned their cable modem, their IP address. It's not used in real time in order to do these types of lookups, but that information is available. And so if we just replicate the whole provisioning process that takes place in the landline phone world on the broadband side of the same company's business, these are the same companies like Comcast and AT&T, then we really haven't changed their processes. And in our architecture, what that does is enable any number of types of devices to connect through that single connection. And we could communicate all the way to the PSAP in virtual real time what the address location is, including the street, the floor, and the unit number if, again, you're in a multi-tenant, multi-story building. So I'm going to walk through at least the prototype, which is pretty basic right now. We haven't, built out all the functionality that we think need to be built out in order to make this something production ready, but it basically captures the high-level pieces that enables this to happen. So we've created our own list for these purposes. And there's an API between our list and what we call our web application server, our 911 server. And over here, we're just using WebRTC for this purpose, so we didn't need to install an app, but we're simulating basically an app that would be on the device, preferably built into the operating system, that when the user initiates a 911 call, either pressing 911 from a phone or a button on an app, it would initiate first a message to our server. Our server would capture that information, see I've got a call from this IP address. Through our API with the ISP, we'd query the ISP to get the hardware information that we have already captured that was already pre-populated into the list. Then we'll query the list, and that will tell us which PSAP to route that call to. And in these purposes, we'll kind of broke it down in some pieces, but we're going to answer the call with a WebRTC PSAP, which in this case, it's going to kick off a SIP call through an interconnect and connect one of two ESI nets and NG911 PSAPs. So why don't, for the first call, if you want to give Josh a call, we'll, today we already have, I'm sorry, go ahead, wait a second.
So in that moment, are you focusing on IoT or a specific device?
It's pretty much ambivalent to the device, so it could be any communication device, whether it's IoT.
On the location for that device would be static.
Yes.
Okay.
Yes. So I'm not substituting. So one of the things I want to be careful to say, we're not looking to substitute and say this is better than ELS or Hilo or AML or what anybody else is doing on the device itself. This is a supplemental data point that can maybe more accurately define the address if it's a mobile phone. And if it's a non-mobile phone, it provides location accuracy for any device that can be mobile. But once it gets to that fixed location that's part of that network, it can derive its location from that network.
So you have two types of devices. One that's designed to be mobile.
Yeah.
My cell phone, I walk around with it.
Yeah.
And then another device that's intent is to be fixed, but it can be easily moved.
Well, I think my laptop computer is easily moved, as is my tablet.
Yes.
And so, as is an Amazon Echo, which I could walk off and say I want to take it to my vacation home, if I had one. But anyhow, and plug it in somewhere else and get on somebody else's network.
So that's where the problem is, because you don't have location discovery.
Well, this is how location discovery takes place. I'm letting the ISP provide my location. My interaction, as soon as I get on that network and I make that 911 call, I'm going to go to a server that's going to say, okay, I got a call from this IP address. I don't know who you are. I don't know anything about you. I don't know anything about your device. I just know I have this request. But I know this is being delivered by Comcast. So I'm going to say, Comcast, tell me the hardware associated with that account in your network. They're going to provide that back. I'm going to dip the list, which we already provisioned for that fixed location, not for the device. The device can move anywhere, which is the beauty of this. So we're not asking the consumer to manage any database of where they're located. We're not asking them to update their location on their house. That's all taken care of by a facilities-based ISP that is already doing the same thing on the landline phone. Is that,
So
am I,
I'll lose you somewhere.
okay,
If I move that physical device,
yeah.
how does the ISP know I moved it?
They don't care. The physical, what, are you talking about the cable modem or are you talking about your phone?
We're talking about the phone.
The ISP doesn't care. You want to go?
Yeah, I think the little point of confusion is the device that we're monitoring or maintaining is the ISP's device that they put at your service address. So any device behind that is proxies for that. So therefore, the location of the devices in that address residence are behind that device. That is the location.
So you're tracking the cable modem.
Cable modem.
Yes.
Or
Okay,
ADSL
all right.
modem or something.
Yeah.
Now I see.
Okay.
Broadband service providers equipment. in
Yeah.
this case, yeah.
So wherever you carry your phone, wherever you connect to a network, your phone is going to automatically pick up a new location
Correct.
that the ISP is going to resolve that for us.
Connected these cables.
Yes.
All right.
Okay. Do you have him on the phone?
Yep.
Okay, so so just before he makes the call, I'll just show you what,
Real quick,
Yeah, please go ahead.
This is an actual simulation here that we're doing. I'm talking to the technician at Newfair's Telephone. Cable modems and ADSL modems, and we've taken the actual data from the ISP's broadband user provisioning service, and we're importing it real time into the database into an active list, and the call that we're going to make is from a PC that is behind a cable modem in that environment. So this is actually a full-fledged call from a device behind a cable modem in this case that has been, that service address has been delivered to the list.
So if, in this case, when Josh makes his call, if he picks up his PC and he drives 3 houses down and connects to a neighbor's cable modem, he doesn't have to do anything. We're going to pick up that new address because of what we're interfacing with New Paris Telephone. And so the screen that he sees is the caller screen. And again, this is WebRTC. I'm going to take this down and bring up wrong one. So he's in Elkhart County, Indiana, so he can go ahead and initiate the call. So this has done 2 things. We can't see him, he doesn't have video on. But I have answered the SIP call. I have a separate SIP client. So I have a separate SIP client. Oh, gee. I apologize. Let me mute my microphone here. So he can talk. Maybe I muted him. But the other thing to show here is, and James, I'll let you can talk to this. But this is the actual Texty application that InDigital now has in production. Maybe not this version of it, but pretty close to it. That you're now installed in other PSAPs. You want to?
I'll take a minute. Okay. One of the things kind of quickly explain is, and I don't want to. It's not a sales pitch for Texty, but it's an example. Hey Josh, can you hold on a second? But it's an example of kind of the technology that we're seeing in an NG911 space. So what Texty is it's an overlay application of using third-party call control. It can sit between a legacy call controller and an NG911 call controller, and it can handle any of the medias that might flow through in an NG911 converged multimedia situation. The example here is we're doing voice, and then if you want to go back to the location real quick, you should have your location still, though, I think. Oh, all right. Hey, can you call back, Josh, again? Just if you can flash it real quick, that'll be just enough. But what we're looking at here is basically the representation of an NG911 object, location object, in a mapping display that might be in a CAD or other mechanism. So with Texty, we've actually received a PIDF-LO object from the WAS gateway, as if the call entered an ESINet as an NG911 call. So one of the beauties, and I'll talk a little bit about some of the kind of negatives and positives of the different location technologies. The positive is that in Charlie's design here, we're exercising NG911 interfaces. You could call it I3. Now, I3 is a large animal with a lot of requirements. We're only touching a few of those here. Additional data is not one of them, but which will be coming. But the example is we've made a call from an application behind a cable modem, queried that location using the service address provided by the vendor or the service provider. We've used the hardware MAC address of the cable modem to find the hardware MAC addresses of the devices behind it, and we've associated that location with that call and delivered it in an I3 standard interface. Sure. That's kind of little bit loaded question, because in I3 and NG911, now remember there's several players in this space, and we as technology people would say give everything you can, that you don't waste data, you provide it. If it's useful, somebody will use it. Dispatchers, when they take the call, are a little bit opposite that. They want focused information directed exactly what's going on. So when you talk about mobile locations, there's a layer in which we see that the mobile locations get collapsed in. But to your point on that, the class of service or class nature of call we're showing here is some IoT type device behind an internet service of some sort. If I was on a mobile device, and one of the slides we quickly went over kind of explains it, if I'm on a mobile device and that device is not using the NIAD and it's using, it only has a GPS capability by using the wireless towers, it would natively use that. This does not replace that technology. Now, if this is a kind of an augmenter to NIAD, some of the information that NIAD is attempting to voluntarily receive from vendors, this system would actually, we hopefully mandated to be provided the data by the vendors, by the service providers. So therefore, this is an augment to NIAD, but it does not replace native technologies that in that device might be better. Now, when that device has a multi-mode client in it, and it can detect it's in a femtocell environment inside a home, and it makes a 911 call, it could take advantage of this technology to have a better location than the device can get on its own. So it's more of a, don't see this as an additional location. The device by nature may have more than one location, but this is a very static one, hard designed and not voluntarily given back to the PSAP. So we're thinking in some cases it's a mode of location that's better than that wireless. In this case, it would be the nature of the device. So if you had a cell phone in your hand, it might be on your Wi-Fi. It might be a participant with NIAD. It needs to make a decision. If it's using a VoIP client in the phone and it's making a broadband call, if this is the mandated technology for location, it should use that location. If it's a wireless mode, AGPS only, it's not on a femtocell, it doesn't have it's the fourth client's missing, the VoIP client's missing, IMS client, I guess, then it might use the AGPS to make that call in the wireless carrier to complete it.
Yeah, I told him, I texted him before that he can go. Hopefully he's gone. Yes. No. No, nothing's what I think is it looks magic, but there's the information is available within the network of the ISP. So I mean, at the starting point, we'll talk about a few of the I don't know if I call them gotchas, but things that need to be solved for which we've kind of developed some architecture in terms of how we would deal with more of the security layer. But if you think about this, what we wanted to come up with and what we're proposing is that we don't want the ISP to have to change any of their infrastructure because that'll be guaranteed pushback. No hardware, no software. We're not telling them to change out their CMTSs, their cable modems, their DSL modems, their routers, their ONTs. Basically, we're coming at this completely absent of all that. But on the back end, we have to interface with their network. So what we've done is we've stubbed out, our API, basically a service that communicates with a service on their side that we've designed that says you populate this service with this information, we'll query that service, and through that we'll get the location of where that call is coming from. And yes.
If you go with some wire and set up another access point that you hook up to, the service provider doesn't have any idea what that is.
Well, it's the other service. So I'm not thinking access point implies to me, if you're saying what I'm saying, is Wi-Fi. Yeah. This is behind Wi-Fi, because Wi-Fi can be moved. The customer can put their own Wi-Fi in. That's a private side of the interface to the ISP. What the ISP gets is the Ethernet side of the router or the cable modem, the DSL modem. That's all they can see. that's not to be moved around. So if a user connects, through that modem, either through, the Wi-Fi or through Ethernet, his address is going to be resolved based on that device. If he goes to another ISP, then my system's going to query the other ISP. It's going to say, oh, this is not from New Paris Telephone. This is from Illinois Institute of Technology, which is what we're going to demonstrate now.
So you're going to do that tunnel, right?
Yeah, right now.
Everything you're dialing with, is that an app of your solicitor telephone?
Well, what I'm dialing with right now is just, through the browser. Yes. Yeah.
Simulated devices.
And somehow you get that together in a
Yeah.
service provider and
Yes. Exactly. There you go. So why don't we're going to simulate a call here. Instead of going off network to a fixed location that we know it's a cable, actually the cable modem in New Paris, Indiana, we basically simulated the ISP here with Illinois Institute of Technology. So we're all using on an IP address right this minute that belongs to IIT, and so we've stubbed them out as our ISP for this purpose. So if we will go ahead and make a call, Bryce will make a call from the Android application there, or his Android device. Okay. So I think did we lose our connectivity? So do you want to do it from your?
Show the PSAP.
Yeah, we are. As soon as we can get this, we may have lost connectivity.
Oh,
Yeah.
Wi-Fi?
Yeah. Okay, so, all right, so this is going to ring. And Carmen's going to answer it.
You do not have her video up there. You might want to put her video up.
So just for demonstration purposes, we're going to show what it looks like here in IIT's lab, or their
Okay, there's a call that's connected. You could see it at the top. You could see the call connected right at the top.
same address here.
Same address, 3241 South Federal. Okay, well, see this one showing all the info, but it's
So the purpose of the demonstration is what we're trying to do is we don't want to change. No, that's okay. We've still got this up, and it's keeping the last call. So we don't want to introduce anything that's going to ask the ISPs to change anything, because they're not going to want to. They're not going to make an investment. We do want them to invest in the interfaces with us that we've created, but we're not asking them to touch their network, which is probably the most expensive piece. They're not touching customers. They're not reaching out to customers. The one making the 911 call doesn't have to be a customer. They just have to be connected to a customer's location or address. We don't want the PSAPs to have to change anything. So I know we've kind of talked a lot about, how are we going to enable WebRTC to be used for 911? Well, that's a broadband service, and we know that broadband is not allowable access point to get into 911 today. So if we wanted to kind of take some incremental steps to get us there, through these interfaces in the SIP connects, we can actually take these types of calls and pass them via SIP through to IIT's PSAP, to the TXT PSAP that InDigital has, or any number of PSAPs that are out there today that are conforming to NG 911. So it's basically PSAP friendly. It's going to be ISP friendly. And in our model, what we're saying is that the client application itself should be part of iOS or Android, so it should be, wireless carrier friendly as well. The other thing I just wanted to point out, and so we'll disconnect this now. We're probably out of time. So to the question that was asked before about which service is, which location is the best location or going to be used and who makes that determination, it could be in the scenario that the location we're providing, whether it's residential or it could be a business location where there is a single demarc at the building for where the ISP provision services, that actually provides the information for routing the call. Because the call routing that we just demonstrated here, from the time you hit dial 911 to the time I get the button to answer it, is less than a second, as opposed to some of these other technologies that Apple has even said are 8 to 22 seconds to actually reliably get the right location for where that call is coming from. So this could actually be used paired up with these other location technologies, one for routing and one for actually providing a better accurate location for other purposes. James, you want to kind of talk to these before we let everybody go?
I'll try to go through quickly. One of the things that when we talk about current location technologies, and I mentioned NIAD as one, and Charlie mentioned it, we know there's the clearinghouse for the device hybrid is coming, or available today actually, recently. But one of the things that we kind of like to focus on is that we're not replacing any of these technologies today. The idea that the ISP has a physical service address, this goes back into the earliest of E911. We leverage the service address of the phone system, so that's really what we're leveraging in this technology. So you've got the ability to estimate location, really honestly, when you're making an AGPS wireless call for E911. In theory, they're estimating your location. It's never real. Device hybrid changes that a little bit. You do get some horizontal position with that, but it's not perfect. Even the NIAD, bless you, unfortunately, the NIAD is leveraging the idea of wireless signals, and wireless signals propagation is not definitive, it's not static. They travel through walls. They can travel through floors and ceilings. So horizontal position will not be guaranteed in those technologies. They're primarily focused on indoor and outdoor mobile technologies. Many years ago, cell phones didn't work inside a house or a building. So E911 for indoor location was not really a problem for wireless because your phone wouldn't even make the call, let alone be able to be spotted. But in regards of the NIAD and other things, we're solving that, but we don't solve it specifically with the target of the device in a building or a room. It's more of where is that generally on the earth, and we extrapolate. And all of this brings down one final answer. There's multiple fragmented sources. And one of the questions we had was about what happens when there's multiple locations, who makes the decision? Well, this is a very big question, very open today in the industry. In fact, West has recently announced a technology to take device hybrid location and mix it with the MPC location given by GMLC at a wireless carrier, CMRS, and they're making the decision for the dispatcher what location's better. That'll be interesting to see where that goes. One of the things that some of the highlights we like to think of is that since we're leveraging that static service address that the ISPs have been generally familiar with for years, E911 they've been generally familiar with giving it out for years, we're leveraging that, reusing it. So in theory, our technology gives you, for the nature of calls that it matches, give you the same quality of location that E911 has for 20 years. Horizontal and vertical is part of this, back to the point of we didn't have a problem finding somebody in an apartment building when they dialed E911 on a landline. Same thing would apply here. Fixed location, we're hitting almost 1.9 million homes today with fixed broadband. It's agnostic. Back to the point on the conversation is we don't really care what devices are in the household. All we care is that the device that the ISP has provided, that the address that it's given in their network is pure and it's statically tied to their service address. Go ahead. Everything they need to do is all done prior to the event of actually making, it's all done prior to the event of actually making the 911 call. Well,
He doesn't know anything about the 911 call
yeah.
until our server queries him and asks for the location information, the data we need.
Does that pick up the call?
Does it come to court?
Because you do have a server that picks up the call 911.
Yes. It will pick up the message, doesn't necessarily
It-
pick
yeah,
up
it-
the phone yet. It picks up a message basically requesting, tell me my location, tell me where to route my call, which PSAP. And then from there, we make
We-
that determination to route
Are you
that.
driving my artificial platform that's consulting us?
Well, remember, what we're talking about are telecommunications applications, IoT devices, and they'll have their own well, that's a little, I mean, yeah. Yeah. Yeah, it would be any form of nature that device that's an IP-enabled device making that call in the moment. So, well, you say access point. I want to make sure we understand it. This is not wireless only. It's IP. It's any edge device that the broadband gateway to the internet is for that user. That when that's the web app. Maybe we go back a couple slides. I don't know if we want to. We're running out of time, unfortunately. But yeah, I could. I don't have any cards with me, but if you can give them a card, then we can talk about. But I don't want to leave you hanging. But yeah. But I think you're heading in the right direction. So the web application server itself, when the IoT software, whatever it is that's making that 911 call, it does have a kind of a requirement. It needs to contact that server and say that a call has been made. And that IP address that it makes that origination from is where we start the process of resolving the location. So the ISPs, they must, for legal reasons, otherwise maintain IPs to hardware devices. They maintain the hardware device to the address based on their service requirements. And that then, through the chain of events, is extrapolated back to the location from the ISP's IP address. So it does require that the application makes a contact. So, if I was doing this in a POTS environment, I would have to have some technology within the class 5 that takes the 911 call and says, oh, I need to go out and make that connection. But when we think about the nature of what we're talking about, that's not a problem because these are already software devices making the calls. There's something behind an internet service of some sort. Okay.
So I thought I'd wrap up. So what we've talked about so far and put in the prototype is kind of kind of the simplest piece of it. Clearly there's a number of challenges to putting something like that into production. First of all, there's a whole security framework that needs to be put in place. Even some of it has to be invented or developed, I won't say invented, but designed and implemented, of which we've got some ideas about using stuff that's already out there today to ensure that we don't have rogue devices trying to call 911, address spoofing, MAC address spoofing, those types of things that need to be built to pretty much enable free access for these types of devices to actually call 911. Today they're pretty much walled off from access. It's only mobile carriers and landline carriers that actually can get through to 911 to terminate their calls. So this is probably the most critical technical challenge. Then you've got more things that are more operational, that they're not hard to do from a technical perspective, but clearly there are things that have to be done, and there's some roll-up-the-sleeves work with coordinating with ISPs, actually getting them to buy into something like this, which today they don't have a business model that says, oh, I want to do this. I do have some use cases that may make it commercially advantageous for some of them to do it. There's some coordination with the mobile carriers for them to use our information or for us to populate the NEAD with our address location where they can get ready access to it. Clearly coordinating with the PSAPs There's regulatory considerations. I met with members of the FCC over the last year. My proposal, which is, obviously not ready to be accepted yet, but if you think about that, 911 today is actually funded almost exclusively through 911 fees placed on mobile and landline phone service. If you are using broadband connectivity for 911, I think the case can be made that you can relieve some of those other services of 911 fees and levy those directly on consumers as a pass-through fee, just like you do for landline phone. If you think about that, if you were to average 75 cents a home network connection per month of 75 cents, you're going to get close to $1 billion a year of additional revenue coming into the 911 system, which would go toward funding support for this type of service as well as advancing NG 911. Obviously, that's left to the politicians and others to carry that weight, but essentially that's kind of one way to enable all these other devices to actually access 911 from broadband and provide these types of location services. And that's it. I mean, I don't know how much time we have left or if we're out of time. Yes. Yeah. It should have been sent. I know I saw it on the WebRTC screen, but I didn't see it on this PSAP screen. On your other PSAP, I think they showed up. What was the other PSAP that you? The Columbia PSAP. Okay, so they're like, you have 3 PSAPs here. So we did send it, that it is in the XML body because we could see it on the WebRTC piece. So yes.
Maybe I missed it, but I'm still not quite sure understand the protocol used between your service, the ISP, and the your service, and whether you assume that you essentially have to become the alley provider for every something. If there were multiple instances of use,
Right. Yes.
how would the PSAP know which one to query?
Well, the PSAP is not going to query in this model. We're going to make that determination before the PSAP gets the call. So let's just say, for conversation purposes, this is the NEAD. So let's just say the mobile carriers would manage that, or West, or whoever's managing the NEAD. The ISPs would first be populating the NEAD with, here is the location of my cable modems or my ONTs or routers every time someone gets service provisioned. So the way the way our architecture is, there's a client application that is on the devices themselves. That client application preferably would be part of iOS or Android or Alexa's or Amazon's environment for their device. And as soon as someone hit a button or dialed 911, as long as it's connected through this cable modem, if you will, it's going to make a call to our web application server. Our web application, you ready for me to wrap up? Cut it? Okay. Should I, I'll take questions out? Thank you. Well, thank you for allowing us the extra time to show what we've got.